So if you have a second to look, basically one of the things we wanted to do was to explain how virtual devices are not limited as virtual resources are limited. That's one exception to the previous caveat that we learned in Module 1. If the host machine doesn't have it, you can't give what you don't have. You can't, if you don't have a terabyte of drive space for a virtual disk on a physical system, you can't set up a terabyte virtual hard disk. If you don't have 16 gigs of RAM on your laptop, you can't set up a virtual machine with 16 gigs of RAM. And what we're saying there is that the physical host, that's a resource limitation, but that's not the same as a device limitation. And I wanted to spend a little more time to explain that. And then I also wanted to explain the assignment which you need to complete in order to do the solution. So we're going to show you some special capabilities in virtual systems that have to do with the way that you can extend hardware features or hardware components. And we also wanted to show you some special things you can do with networking for better reliability and security. And then we also wanted to show you how to work those custom solutions in a manner where if you have to roll back the system changes, you can roll back to a previous state. And so the final study guide has been shortened so that it's much quicker, simpler to get into. You should be able to see this on your screen, I think, right? Can everybody check to make sure you can see this on your screen?
Yeah, I can see it.
Okay. And so one of the things that we wanted to explain after we talk about how virtual devices are not limited, even though virtual resources are limited, we wanted to talk about the snapshot. So last week we covered some stuff about the virtual hard disks, and we showed you a cool way to create a virtual hard disk that you can share between systems, and that was demonstrated in class. And then we started working with network interfaces, and I've done some additional research on that, and so we know how that works much better now. But one thing we haven't done is talk about the snapshot feature. So basically, when you have a virtual device, your operating system creates a virtual instance of that device on your physical machine. So even if you're not running VirtualBox, can everybody see this screen?
Yes.
Okay. So your operating system, in order for you to be able to multitask and to be able to run multiple applications simultaneously, your operating system creates virtual multiples of the same devices that each of the separate applications use. So for example, and I'm in Device Manager here, so if I go into Control Panel, I can look at Device Manager right here, and that's how I get into that. If I right now I'm running 4 different tabs in a web browser. I'm streaming video to you, so I'm sharing the screen with Zoom. And I'm also using wireless peripherals. So I have this Bluetooth mouse and a keyboard that I'm working with. So all of those things are using, I mean, the Bluetooth is using Bluetooth, but basically in a case where I have multiple applications that are using the wireless adapter, the way that your operating system gets this to play nice is that it creates multiple virtual instances of that device in memory. So your RAM memory is very critical. The more memory, the RAM memory that you have on a system, hardware, the more you can do, the more you can multitask. But what you see here is the RAM memory address range that's reserved for this wireless adapter. And what's happened is that when I start up each application that uses the network connectivity, a virtual wireless adapter is provided for my web browser, this tab, okay? If I open up another tab and I Google YouTube, FPGA chips, right? And I start watching a YouTube video. Well, now that's really a separate application.
All right, so I was recently at the teardown.
And so I have these two applications running. I'm running Zoom, as I said. So all three of those fit into those three virtual adapters. I can look at Ethernet or Wi-Fi. So what happens is that, where's my device manager? There it is. My wireless adapter basically has three virtual wireless adapters living inside this. So a virtual representation of the wireless card is created in memory. And there's three of them, one for this web browser tab, one for the other web browser tab, and then the third one for the Zoom session that I'm conducting with you. And there are these things called interrupt requests. And those interrupts allow me to switch between tasks without crashing the system. So I can switch between this task, I can switch to this task, I can switch back to Zoom again. And what I have is a case where those multiples are being created. Well, it wasn't long before somebody realized, wait a minute, a host machine for a virtual system may have enough RAM to create a virtual keyboard when it doesn't have one, or a virtual display adapter when it doesn't really have one, or a virtual monitor when it needs an extra screen. And the actual physical machine doesn't have one. And how is it able to do that? Well, it's able to do that because the operating system creates virtual multiples of device types. And in some cases, you can have a virtual machine where you can create a printer, for example, right? I have printers. I can create a fax machine. I don't have a fax machine on my physical laptop, but I have a virtual fax machine that was created in memory because when they built a physical fax machine and connected it to a working Windows system, they took a look at what was created in the virtual device and they realized, wait a minute, I can have this same virtual device and put it in another virtual machine that doesn't even have a physical fax machine. So it's true that if you only have 4 CPU cores, you cannot build a virtual machine with 8 cores. You only have, so we're talking about resource levels. We're saying we only have so many cores, we only have so many gigs of RAM, we only have so many gigs of hard drive space. Those are host system resource levels. And you cannot create more virtual machines that use more than what you have on the host to work with in terms of raw resources, disk space, memory gigs, RAM gigs, and CPU cores. But when it comes to the other devices, you can create a controller in a virtual machine that does not exist Here I have a SATA controller on my physical laptop. But inside my machine, my virtual machine, I can create a storage controller. I can add one if it's not running, and I can pick an older style that the laptop doesn't even have. So one of the distinctions we want to be clear about is that virtual devices don't have to necessarily exist on the host machine in order for a virtual device to be created on the virtual machine. Does that explain our first point of interest in our study guide? We want to explain how virtual devices are not limited as virtual resources are limited, right? So you can't provide any more resources to a guest beyond what it has in terms of its own resources. But that's not the same as virtual devices. And why can they do devices? Why can they build a virtual device into a virtual machine that doesn't exist on the physical machine? Because this innovation with operating systems allowed computer scientists to create virtual digital components. The rest of you have had computer architecture or are taking it right now. Is that correct? Is that a correct statement?
Yeah.
Okay.
Yep.
So does everyone remember the hardware simulator?
Yeah.
Okay, so you can design logic gates, physical logic gates, but you can also write code that does the same logic, yes?
Yeah.
So you can have a software function that produces the same result as the hardware. It's just that the hardware is 1,000 times more efficient, right? So
Yeah.
that same idea holds true here. If we can create unique digital components, then we can offer those in a virtual machine, even though we don't have that exact physical component in the host machine, so long as we have enough memory, so long as we have enough disk space, so long as we have enough CPUs to do the virtual calculations and data processing to make that happen. Are there any questions about this first? So here I use the example of the SATA controller and the SAS controller. So this one's a SCSI, serial attached SCSI controller. It's an older server-based controller. SCSI is an older data disk management and RAID technology. SATA is consumer. It's what we find in PCs and laptops for consumers and in workstations, but not on servers. So you can have a virtual machine that runs a SATA disk controller, a virtual machine that's on a host that has a SATA disk controller, but you can have a server that has a SAS controller that runs in SAS. Are there any questions about this first thing?
No, sir.
Okay. So basically, for the B and C sections of your study guide, what we're going to do is walk through the same, your solution, you're going to create the same kind of thing that we did in class. You're going to perform the same steps that I did last week when we created a separate virtual disk and then released it for use with other virtual systems. And we want you to experience the same kind of thing. So if you haven't had a chance to read this, it should ring a bell when you do, because you're like, well, I thought Kentop did that last week in the class, and I did. And I'm going to have those videos out there so you can reference them. Yes. You had a question?
Okay, I was going to ask if you can upload them. Yeah, look, I was going to ask if you can upload them, but you just said you're going to do it. So
I am. So that was in the 16 November session. Then the network session here For sections D and E, network features that enhance reliability and security, we demonstrated that, or parts of that, on 18 November. That was Wednesday of last week. That'll be out there. But basically your solution, you'll walk through. Section 2 of your solution will be creating your own network interface with the following different settings. So here we've broken out what each of those different settings mean. I went on to after our class on Wednesday, I went on to the virtual machine and I tested every option. And what I found was that there were some very plain things, absolutes, like if you do NAT, and we showed this in class, each of the virtual machines can't see each other, but they can talk to the host and they can get on the web, right? If you do NAT network, the virtual machines can do the web, they receive a different local IP address, they can ping the host, and they can ping any other NAT network VM. So they're basically connected to anything. The only caveat is that it creates this double natted network like the NAT does. If you're using wireless at your house, you're already natted, and then you do NAT again on the virtual machine, so you're double natted. With the bridge network, the one caveat is that it's the most insecure. So the benefit of a bridge connection is that you avoid the double NAT, okay? And that's better when you're trying to use like cloud-based gaming. If you're doing network hosted gaming tournaments and you're using a virtual machine to do that because you can, then the bridged option is what you want. The only problem is that this basically sets up the greatest exposure because the VM can see the host, the VM and the host can see all other hosts, and they can see all the clients on the network, on your local network. So anybody that's connected to your wireless network at the house, your virtual machine can get into that Kool-Aid. So the bridged option is the most flexible and trouble-free, but it's the most insecure. These other three connections or these other two types of connections are a little different. So this one by far is the most secure, okay? It is the most secure by far because the internal only network, the virtual machines cannot web. If they receive an automatic IP address because they're set for DHCP, then they'll get this APIPA address. But if they're Linux doesn't work like that. So Linux is just going to get a non-address and you have to set it manually. So that's one of the things that's a caveat. There's no DHCP with an internal network. So the DHCP options don't automatically assign addresses. It is the most secure because in order for these virtual machines to talk with each other, they're isolated. They can't talk to the host. So they cannot they can't talk to the host, they can't do the internet, they can't interact with other, but they can interact with other virtual machines. So they can't see the internet, they can't see the host, and they can't see other clients on your home network. The only thing they can do is interact with other virtual machines, but you just got to set it up manually, which means you have to manually assign IP addresses to the Linux machines if you have Linux machines running. So we go from the most flexible connection and the least secure to the least flexible connection and the most secure, right? Here's the host-only adapter. So the virtual machines cannot web, but they can ping the host, and they can ping other VMs. So they can ping other client addresses in the local network. The only caveat is that you have to set up this host-only Ethernet adapter in the separate menu, host network adapter menu. And that's, again, we touched on some of that last week. I wanted you to know that if you want your virtual machines to interact with other virtual machines and not to interact with clients on the local web, on the local wireless, this is your best option. Because if they can ping the hosts, they can also ping other, well, it says they can ping any other host-only adapters. So I set up a set of virtual machines and I tried all this. So this is the most exposed, and I would say in most cases you want virtual machines to see each other. NAT network and host-only adapter are your two ways to go. Once again, if you want virtual machines to see each other and you want better security, you're going to want to use NAT network or host-only adapter. And the host-only adapter basically isolates those machines from other systems better than the NAT network. The NAT network can see the host and see other machines out there. Any questions about the different network options?
No.
The last section, the reason you have a separate assignment is because we want you to, if you don't have a lot of disk space on your host, we want you to delete the Linux machine that you created previously. Now, why is that? I mean, now if you have lots of hard disk space on your host, you don't have to delete it. But we want you to be able to experience the snapshot features that roll back system changes so you can see how it works. Now, the whole time, for the whole course so far, we've been using fixed allocations for the virtual hard disk. We haven't accepted the default, which is dynamic allocation, okay? So dynamic allocation allows you to roll back system changes efficiently. You can still do snapshots with a fixed allocation, but if you do, you're probably saving the entire hard disk every time you do a snapshot. It's not kind to your disk capacity. So what am I saying? I'm saying that we had, I'm going to go ahead and log in and shut this down so you can see how I configured this virtual machine. How many of you set up an Ubuntu system? Anybody?
I did, yes.
Okay. So you set up an Ubuntu system. And if you look on your file explorer and you click on this PC, and you're kind of like I am, can everybody see how many gigs I have left?
Yes,
Yeah.
we seen it.
Right. So let's say I have a Linux system with 20 gigs of hard drive space, or 10 gigs of hard drive space, or 16 gigs of hard drive space, and I take multiple snapshots 3 or 4 times with a fixed disk. So I get multiple copies of the hard disk. How many times can I do that before I run out of free space and I crash my system? Like if I had 16 gigs, if I did it twice, I'd have the original virtual machine. First snapshot, that's another 16 gigs. Second snapshot, that's a third 16 gigs. That's 48 gigs, right?
48, yeah.
Yeah, I'm running out of space in a hurry. And the reason the snapshot feature works so well is because when you're dynamically allocating disk space, it only uses what it needs. It doesn't take the whole, it doesn't allocate the entire virtual hard disk space all at once. But you created a Linux machine, Ubuntu, and so did I. And I deleted it. I basically right-clicked it, and I removed it, and then I said delete all the files. Now, I'm not going to do that right here and right now, but I wanted you to see that that's what I want you to do if you have a machine with limited hard disk space. If you have plenty of hard disk space and you want to keep your Ubuntu machine, don't delete it. Okay? Is everybody with me on that?
Could you repeat that? You were in and out.
If you have plenty of hard disk space and you would prefer not to delete your Ubuntu your virtual machine, then don't.
Oh, okay. Thank you.
So on the assignment, when we look at the assignment, right? So let's look at the assignment. If you have limited hard disk space, you're going to want to delete the Ubuntu virtual machine. And you're going to want to install instead a Debian system. Now the Debian system takes up much less space. It's still Linux, it still works the same way as Ubuntu. But instead of being many gigabytes, it's only a couple of 100 megabytes. So if you use either this link or this link, you can download a 600 megabyte ISO of your Debian. And if you need to delete your virtual machine, then you can do that now, and we can walk through the steps together. But basically I said, then view the screen shown in the 3.1 assignment steps folder and do likewise on your own system to build the new system. And then after step 10, so this is the other part, when you're walking through the screenshots here, when you get to step 10, after that you have to start your virtual machine to continue on with the Debian setup. And then once you're done, you can take a look and see how a 16 gig dynamically allocated virtual machine really only uses 4 gigs. Yay! And then when you do snapshots, they're not huge. So you can make a lot of changes, you can try a lot of things, and then if you want to roll back your changes, you can go back to a previous snapshot. And that's what we'll demonstrate in the last section of the solution. But to do that, you need to have a virtual machine with dynamic allocation. And to date, the only ones we've done were fixed. Okay? So when you click into this folder, here's step 1. And I'm gonna collapse this then. Let's see. Where are you? There we go. Everybody see that? So here I'm showing you deleting the Ubuntu, and then you download the Debian ISO, and you want to check the hash. So let's talk about that for a minute. When you download the Debian, it's going to be, if it's untainted, exactly 695 megabytes large, or 728,760,320 bytes. If it's tainted or infected or corrupted, it's not going to have that same size. One way to guarantee that it hasn't been changed or infected with malware is to use something called a hash. And there's a cool utility called Md5 and Sha Checksum utility, and it allows you to download stuff and then get the hash they give you, and then you check it. So I'm going to walk through that right now. On the website, the Debian, on the website that I used to download the Debian, it says that the SHA-1 hash has this value. It ends in 5 Foxtrot 57 Echo Foxtrot. Does everybody see that? 5F57EF.
Yeah.
So if you get a precise copy, a clean copy, an uncorrupted copy of the Debian, what you can do is take this checksum utility and generate the SHA-1 and see if it matches. So I'm going to take this value and I'm going to copy it, because that's what the website told me. And then I'm going to go to this utility, and I'm going to uncheck the MD5, the SHA 256, and the SHA 512. I just want to generate the SHA 1. But I'm going to take my hash and paste it here. So that's the one they gave me. And then I'm going to point this tool to my Debian file. And I'm going to say open. And now it's generating the hash. So what it's doing is it's doing a mathematical comparison, and it comes up with all capital letters of the same hash. And then I click the verify button. And if it matches, it says, hey, the hash matched. That's a way that I guarantee that I got a clean, uncorrupted copy of the file. So where do you go to get the Debian? In your assignment, there's a link. And if you click this one, you want to pick the one for the CD, and you want to click on AMD64. That's the one you want. AMD, not any of these others. ARM processors are the processors that are found in cell phones and Raspberry Pis, and these are other types of processors. You can get a DVD, but that's gigabytes in size. This is only 650 megs, so it's a very, very clean, very efficient, and it'll download quickly, much faster than watching a Netflix video. Okay, so I wanted to give you something that would work. On this same page, it talks about the hash. So as you scroll up, on this same website, they have the listing for the hash, and I'll go ahead and post that since I have it already. So you can check to see whether or not you got a good result. Are there any questions about this part of it?
No.
Okay.